And on we go. We've spoken about context, we've spoken about hazards, what a hazard is, and then we had a big discussion around putting your mind around thinking about the hazard. What are the characteristics of these hazards? Are they big? Are they small? The shape, the content, and the way in which they can possibly harm you, the energy that it contains and how that energy is useful or it can be harmful. This now brings us to the next stage, and this is where we make a list, where we identify all the different ways in which that hazard that we just identified and characterized, we are now going to list how that hazard can possibly injure us. So now we are going to look at the events that may lead to injury or harm involving the hazard or multiple hazards. And those we can call incidents. Let's first talk about the definition of risk. Risk is it's like a measurement. It's like forming some idea of the quantity or the amount of the combined effect of both the probability or the chance or the possibility of something happening and the consequences of the event when it happens. Now, some people will tell you that it's consequence multiplied by likelihood. That's not true. So again, when I am considering an event, and later on you'll see that an incident is an unplanned event, so I am trying to use my imagination, my knowledge and my experience, and I'm trying to predict, I'm trying to look forward, and I'm trying to see these events that I identify, what's the probability that they may happen, and how bad will the consequences be? If the chances are high that it will happen and the consequences is great, we say that the risk is high. If the probability of something happening is very unlikely, it's not going to happen at any time, and the consequences are not that great, then we say the risk is low. Now, we can measure risk what we call qualitatively or quantitatively. We'll talk about that later. And there are quite a lot of different risk assessment tools available. But please, never tell anybody, including me, that risk is likelihood multiplied by consequence. There is a risk involved in everything that you do. Every time that you take a breath, there's a chance that there might be bacteria or viruses in here. And you breathe it in and it may attack your body. Every time that you put one foot in front of your other foot, there's a chance that you may misstep and that you can fall. Every time that you cross the road, every time that you pick up a knife, every time that you eat something, every time that you deal with a chemical, there is the possibility of an unplanned event, and that unplanned event can have consequences. Now, when we talk about a hazard, we talk about the size and the energy in there. One thing that you need to understand is that every hazard has got what we call an inherent risk. Inherent means it's built into the thing. Okay? It's part of it. A knife, most knives have got a sharp edge. If the knife does not have a sharp edge, it's not a knife. It's a palette knife. It's something that you use to spread something. It's not going to be something that you cut with. So inherently built into cutting tools is the ability to cut. That's why we have them. Inherently in some chemicals like petrol is the ability to burn and explode. If you take away the ability, the energy of petrol to burn and explode, nobody will buy it anymore because it will be no better than water. Actually, it will be worse than water because you can't even drink it. So, built into certain things is always a potential for an unplanned event with consequences. A vehicle, if it's controlled, fine, but if something happens, it's got weight, it's got some electrical systems inside there, it's got a battery with chemical content, it's got fuel inside there, and if you put it into movement, if it hits something, then it's going to cause harm or damage. But if you get a vehicle that doesn't move, it's not a vehicle anymore. Okay? So inherent risk is part of whatever you are dealing with as a hazard. Take away that inherent capacity to cause harm or to do work, then it won't be what you buy it for and what you use it for anymore. However, people go and we also, as soon as we start interacting with this hazard, as soon as a person starts driving a vehicle, as soon as a person starts using a knife, as soon as you start storing chemicals or using chemicals, as soon as you climb on a ladder or on a scaffolding, what happens is we add another element, which is add-on risk. So a knife inside a drawer will have a sharp edge, but the moment that I pick up that knife, I now add on risk to a human being or to whatever I'm going to cut or harm. If I drive a vehicle, then I now create more risk that vehicle, I increase the probability of something going wrong, and I increase the severity of the consequences. A car parked, it's got the potential for harm, but as soon as I start driving it, I increase that potential for harm. Here's an example. There's a building, it's a hazard, and I have an aircon, there's a hazard. But as soon as a person starts working in this uncontrolled fashion, then suddenly there's harm. Maybe the air conditioner falls on top of somebody else. Maybe somebody slips when he grips the spell and he falls out of the window. Okay, it starts with the air conditioner, but then humans go and they interact with the hazard, and because the weight or the position or something like that, the person is now in harm or in the way of harm. Here's another example. Here we have a guy that is working in a fuel station. There's a petrol pump and whatever, and he's working with a grinder, which is another hazard. His vehicle, which is another hazard. So there's at least 3 hazards here: fuel, vehicle, grinder, and then we have the steel structure, which is another hazard. And what he is going to do, he is going to cut with this angle grinder on this piece of steel. When these 2 hazards, the angle grinder and the steel, when they come together, they will create sparks and they will create flying objects. And what can possibly happen is that this grinder can slip and cut the guy. He can slip and fall. Grinder hit him on the head, maybe even while it's running. While he's cutting the steel, flying projectiles can enter his eyes. Those are all incidents. So what I'm doing is I'm going from the hazards and I am now inferring incidents. And I'm also looking at the interaction of different hazards to create other incidents and consequences. And if there are fumes from petrol, which is a hazard, and its character is that it's volatile and it's explosive when it's available in air at the right concentrations, and I put an ignition source with these fines, not only do I have the physical event of this guy falling off, getting cut, getting a projectile in his face, damaging himself, damaging the vehicle, damaging the tool, but I now also create the potential incident or the possibility that there might be an explosion and fire. Now, without this human being using this tool in this environment, these hazards on their own would not be interacting. But the moment that the human starts working, or we mix these things, then we increase the probability of something going wrong, and we also increase the severity of something when it does go wrong. Here's another example. It's a real life story where this guy, I think it was in Nigeria, he wanted to impress the spectators. The lion was in the cage. The lion is a hazard. This is a barrier, as we've discussed, and it's supposed to be between the target, which is the man, and the hazard, which is the lion. But this man chooses to overcome the barrier. He chooses to penetrate this barrier so that he creates the potential for the hazard, the lion, to get into contact with him. In other words, he created closing potential. And then the lion said, okay, let me then grab your finger. This guy panicked and he pulled, because this lion, if he was going to pull him, he's going to get hurt. And eventually he pulled so hard that the lion walked away with his finger and he walked away with his life. Right, so the lion on its own has its own character and the risks. The barrier is placed between the target and the hazard to protect. The target then chooses to bypass the barrier and to create closing potential for the hazard. The hazard then takes his jaws and he transfers energy to the finger, and then he starts pulling. And consequence is that the guy loses his finger. Okay, can you start seeing how the hazard barrier target then gets together? So these risks, these incidents, a risk is connected to an incident. And an incident, in the context of health, safety, and environmental management, is an unintended event that disturbs normal operations. It may cause actual damage or injury. In the old terms, we used to call these accidents, but nowadays we don't talk about accidents anymore. They are all incidents, and we say that it's an incident that actually caused injury or harm, or it's an incident that nearly caused incident or harm. And we call these things that are nearly causing harm, but they didn't quite result there, we call them near misses or potential harm incidents. Fancy words, but understand that an incident is an unplanned event. You don't plan to fall unless you're a stuntman. And even then, if the stuntman falls incorrectly, if he falls badly, that would be the unplanned event. Falling in a controlled fashion is still a planned event. The moment that things go wrong, it's normally when it's an unplanned event. What do we do with incidents where things nearly caused harm or damage? Well, we can still learn. We say, shoo, that was close. Next time I walk past here, I have to open my eyes. Or, wow, the hammer nearly hit me. I really have to be a little bit more careful. My hand is getting tired. Maybe I should rest so that I don't destroy my whole finger. So how do we predict these incidents? We understand through context where we are working. We've done hazard identification and we looked around and we observed all of these items that if they contact me and there's energy behind them, then it has the potential to cause harm. Even while I'm using it in a controlled fashion, if it goes out of control, that controlled energy will then become harmful energy. How do I define what can happen somewhere in the future? Well, firstly, you need to understand, and that's why we took you through the process of understanding the potential behavior of a hazard. What does it do? What should it not do? What needs to happen before this thing gets out of control? And we need technical knowledge. So I must understand the the technical background of a hazard, of a hammer, of a saw, of the chemistry, of a machine, of driving a vehicle. I must have technical knowledge about the hazard. I must also have some experience about this hazard. So I must know what kind of incidents have happened in the past, not just with me, but also with other people regarding this kind of hazard. So I can go on Google and I can go and speak to experienced people and say, this thing, how can it harm me? And how bad will it be? And they will tell you that an angle grinder, if you put the wrong disc in the angle grinder, it may shatter and it may penetrate your head. And if you want, I can give you some real-time footage on that. They will tell you that an angle grinder, especially the big ones, if it catches you in what they call the triangle of death, there at your crotch, at the top of your femur, where your femur artery goes through, if you cut that off, you're dead in a few minutes because you will bleed out. They will tell you that if you use a screwdriver and you use it in your hand to do something and you slip, then that screwdriver can stick right through your hand. They will tell you if you cut with a sharp object towards you and it slips, you can cut your face, you can cut your neck, you can cut your hand. And once again, you can damage your hand so much that it doesn't work anymore. So you need technical knowledge, but you also need experience. And then you also need a little bit of imagination, because you need to take the past experiences, the hazards that you are dealing with, your technical knowledge, and then you need to look in your imagination, you need to look forward a little bit. And you say, well, how can these things get together? Now, we don't want any fancy flights of imagination, all right? We don't want you to think up impossible scenarios. So it's got to be reasonable. So we use a combination, technical knowledge, experience, and imagination, and we try and foresee incidents that may happen in the future based on all of those three elements. One of the key things that I would be looking for when I'm looking for an incident, if everything is stable right now, if a hazard is there, I am here, and there are no injuries happening, what needs to change for me or for anything to trigger a chain of events that will cause harm? The example of the guys with the air conditioner. The air conditioner was sitting there. They needed to do a job. What did they do? What changed? Well, a guy accessed that air conditioner in an unsafe way, and that put him at risk and maybe people below him. The guy in the zoo. What changed? He was safely behind a barrier, probably behind a handrail, far away from the cage, but he wanted to impress people. So he climbed through this handrail, and he then went up to the lion, stuck his finger through, and then started petting this lion. And the lion started to pet him back. Okay. So what needs to change? If there are things on the floor, what needs to change? Well, I need to walk over there and I need to hook my foot behind it, and then I will lose my balance, and then I will fall, and then I will get hurt. If I work with chemicals, if I worked in the right way, everything is under control, pour the chemical from one canister into the other one, no problem. Where does the change come in? The moment that it splashes, the moment that it spills, or if I work with petrol or something like that, the moment that there's an ignition source. So when I'm looking for incidents, I need to use my technical knowledge, my experience, and my imagination, and I need to see where changes can happen, because those will be the key to tell you what the incidents are. So change, what do I mean by that? Hazard pathways, in other words, how this hazard is going to impact the path that is going to follow to hit the target, is characterized by that concept of change. And a change in a target's condition, physical otherwise, or in the position of a hazard, can be detrimental or undesired. So what we need to do is we need to think about damage mechanisms not just the purely mechanical ones, like I said, behavior, very much behavior, doing something's unsafe. That will start the event from happening. And that will lead us into controls other than the physical barriers, which means training, administration, inspections, procedures, and so on. Okay, so summary, I need to identify the hazards. I need to understand the hazard. I then need to look at how this hazard can impact the target, and what I'm looking for is for a trigger that will start a chain of events. I'm driving on the road. What is going to cause an accident? Somebody running in front of me. Another vehicle is stopping in front of me. Me losing control over the direction and the speed of the vehicle. The road conditions changing. Mechanical failure on the vehicle. And that will then start a chain of events. And once I know that chain of events and I know those triggers, if that trigger is related to behavior or conditions, I can then put control measures in place, which are not necessarily physical barriers. When I look at change, I need to ask, what attribute of that hazard is being changed? Position, energy level, barriers taken out of place? Do I bring it closer to a target? Who is the actor? Who is making this change? Because a hazard doesn't move on its own. So what starts this change? Who is the actor? And how do they act? Now, if somebody does something, if there is a change, if the actor or the action happens, what will be the possible immediate unwanted effect of that change? Because an event is an unwanted event. An incident is an unwanted event. I need to then consider, with this chain of events that I've identified, what barriers and controls do I need to put in place to make sure that either the trigger is not pulled, the initial action is not done, or if it is done and the hazard is released, I can then protect myself. Not only do I have to ask whether the hazards or the controls are in place, like the fence over the lion, rules and procedures, I need to ask myself, if I use this stuff, is it going to be effective? I always use this story of, it doesn't help to carry a condom in your pocket. And also it doesn't help to carry a condom in your pocket if it's got a hole inside. Because even if I'm going to use it, it's not going to be effective. It's the same with a hard hat. If I wear a hard hat, but I walk over a 5-ton suspended load, that hard hat is not going to protect you. All that's going to happen is that we will have a squashed body with a hard hat inside it, all right? So it doesn't help if I put barriers and controls in place, but they're not effective if I don't use them. It doesn't help I put traffic signs up to regulate the traffic so that we don't drive into each other if people are just going to drive over red traffic lights, over stop streets, they are going to speed, they're going to pass on solid white lines. Sorry, then those traffic rules will not be effective. Another thing that you need to ask, are those employees competent to apply those controls? Do they have the knowledge? Do they have the tools? Do they have the skills? Have they practiced this? Have they been instructed before? Have they been warned about the possible dangers? All of those things that we just spoke about are just aids or tips for thinking so that you can identify the incidents. So I need to come from context through my hazards, and then I identify incidents. And later on, we are going to put controls or barriers in place when these incidents happen to either prevent them from happening or when they happen that we can reduce the consequences.